My name is Darrell Bigalke with QualiTru Sampling Systems. I want to thank the 3A staff for inviting me to participate in this seminar. I always welcome the opportunity to talk about dairy product quality and dairy product quality control. A little bit about myself. I was born and raised on a dairy farm. I have a master's degree from the University of Minnesota with an emphasis in dairy microbiology. I worked for Ecolab for 10 years, where I primarily was involved in troubleshooting contamination issues in dairy processing plants. In 1983, I formed QMI, where I continued to do consulting work, but I also started to manufacture and market the QMI aseptic sampling system. Currently, I am the owner of QualiTru Sampling Systems. One thing I want to point out, I've been asked to talk about environmental contamination. Most of the time we think of environmental contamination, we think of floor drains, airborne contaminants, contamination on hard surfaces, condensation, etc. However, I want to talk a little bit of different type of environmental contamination I call environmental contamination. Why cleaning and sanitizing aren't enough? Without good cleaning and sanitizing, without good sanitary design, without good hygiene, we will have contamination. However, even with very effective sanitary design, cleaning and sanitizing of product handling equipment, we can still have contamination. This contamination is primarily due to what I call environmental contamination or in-process environmental contamination. The rest of my presentation will discuss these sources of contamination. Environmental contaminants can occur, in-process environmental contaminants can occur through a number of processes, from water, chill water, glycol, airborne contaminants, condensation, compressed air used like in leak detectors and blow molded containers, are used in air blows, and personal hygiene are things that can affect contamination in dairy products. For those of you who don't know, chill water and glycol are coolants used in the dairy industry, and they can be a significant source of contamination. I will be discussing those in upcoming slides. Microbial contamination in dairy products. The dairy industry must be a very clean industry. Milk is an ideal growth media for bacteria. Bacteria that normally would not grow in environments can grow in milk because of complete nutrients, complete oxygen supply, absence of any kind of inhibitors. It's just an ideal growth media. There are many sources and mechanisms of contamination of dairy products. We'll be discussing those coming up. Psychotropic bacteria are the primary problem with premature spoilage of dairy products. Psychotropic bacteria means bacteria that can grow at refrigeration temperatures. Testing must be designed to detect these very low level of contamination. Psychotropic contamination is determined to be the determining effect on shelf life. It's the growth rate of the contaminant that is the main factor. Continuous monitoring is needed to have a complete quality control program. Okay, this slide here shows the types of bacteria we find in spoiled milk. The first one is gram-negative rods. Gram-negative rods are always post-pasteurization contamination. Gram-negative rods will not survive pasteurization process. They can cause defects such as bitter milk and putrid milk. But the significant thing about gram-negative bacteria is normally very psychotropic, normally very capable of growth at low temperatures, and they're always post-pasteurization contaminants. So if we find these bacteria in our product, we know we have a problem from the pasteurizer on. Gram-positive cocci are thermoduric organisms, or they can be environmental contaminants. They usually cause acid souring and ropiness in our milk, but these are most likely to be environmental contaminants. I have found these to be present in compressed air many times. The third group of bacteria is gram-positive rods. Gram-positive rods are thermoduric, meaning they can survive pasteurization, usually result in sweet curdling and bitter flavors in milk. Bacteriological hazards that we find in milk are foodborne illness potential is Salmonella, Yersinia, Listeria, coliforms, Campylobacter, and Staphylococcus aureus. One thing I want to point out is that dairy industry had the misfortune in the early 80s having an outbreak of Salmonella in a dairy processing plant. shortly after that, there was an outbreak of listeria in a cheese plant in California. At that point, the regulatory agencies in the industry got together and decided we have to do something to reduce the potential for contamination of these pathogens. They started implementing more quality control programs and went from basically not necessarily evaluating the product exclusively, but evaluating the process. One thing I will say, the dairy industry has adapted quite well. There are very, very few incidences of foodborne illness outbreaks from dairy products, with the exception of raw milk. And I think the dairy processor give himself a pat on the back for producing very safe products. A little bit about the bacteria. We talked about these gram-positive rods. Normally they're thermoduric. Normally they come from raw milk. Normally they come from equipment that's not clean for raw milk handling. These bacteria can be spore formers, usually are spore formers. The spores are activated during the pasteurization process and it can grow, resulting in spoilage. Gram-positive cocci are also normally thermoduric bacteria surviving pasteurization, but they can be environmental contaminants. As I mentioned, we do find these quite often in compressed air. Gram-negative rods, again, these are the bacteria that are very psychotropic, very capable of growth at low temperatures, and very likely to cause premature spoilage. Spoilage as low as 10 to 14 days in fluid milk. And another significant thing about these bacteria, they will not survive pasteurization. So if we can find these or identify them in the process, we know we have a point of contamination. Compressed air, I want to say a little bit about compressed air. Compressed air is usually something pretty much overlooked by the dairy processor. Compressed air is normally not a problem if it's kept dry. However, air dryers are used in dairy plants. Oftentimes these air dryers are overused, lose efficiency, and do not remove all the air, creating condensation. The condensation then becomes a source of contamination. One of the things that the dairy people will argue with, say there's filters in the air lines that are supposed to remove the bacteria. What I have found is if filters get wet, they actually grow bacteria, become a source of contamination. One thing I've found that we can use to identify if contamination is a problem with our blow molded plastic containers. As you know, compressed air is used to determine if there's leaks in the plastic containers. If the air is contaminated, it will contaminate the plastic container, resulting in spoiled product. What I recommend processors do is routinely take some plastic containers off the line, place 25 milliliters of sterile milk in the container, rotate it around, let it set for 2 or 3 days, then do a plate count and determine if the type of bacteria that we find in those previously sterile milk is the same type of bacteria that's causing our spoilage. Personal hygiene is another important factor to consider. Every dairy plant should have a training program for their employees, as well as a policy that fits with keeping products safe. For example, there should be a policy that no employee should be on the production floor that has any kind of illness or any kind of infection or any kind of thing that should make them stay away from the production floor. A little case history. I was working with an ice cream plant. This ice cream plant was a small ice cream plant, and they were making a premium ice cream by melting butter and putting it into the ice cream mix. The guy that was in charge of unwrapping the butter and melting the butter had a staph infection on his arm. The staph infection then got into the ice cream mix along with the butter. The ice cream mix and the butter were held at elevated temperatures overnight, and the staph was able to grow. The staph grew. The next day, they pasteurized the ice cream mix, which killed the staph bacteria, but it did not inactivate the toxin. The result was 250 people got sick from the Staphylococcus enterotoxin. This lesson should be made that everybody should adhere to strict policies of personal hygiene and plant policies. One thing to keep in mind when we're troubleshooting premature spoilage problems, if you look at the psychotropic bacteria, it's the growth rate of the bacteria that really determines the shelf life of the product, not the amount of contamination. This slide here shows what happens if we have 3 different bacteria, one with a 6-hour generation time. And just a reminder, generation time is when one bacteria becomes two, two becomes four, four becomes eight, and etc. If a bacteria has a generation time of 6 hours, which is probably capable of an organism like Pseudomonas, a gram-negative bacteria, and if it's in the product at even less than one bacteria per 500 milliliters of product, we can have spoilage in about 15 days. On the other hand, if that same bacteria has a generation time of 15 hours, spoilage won't occur until 25 days. So when we're troubleshooting these spoilage problems, we got to keep in mind that the growth rate of the bacteria is the primary factor affecting quality. I just want to point out from this slide what happens with the glycol in a lot of dairy plants. This particular slide happened when one day I was having lunch with Bill Coleman, who was running the Department of Dairy for the state of Minnesota. And I said, Bill, I don't really agree with how you guys go into a dairy plant, take a sample of glycol, and you test for coliforms. The test for coliforms is at a very elevated temperature, and you're taking a sample from a very cold environment. And I said, if you do a psychotropic bacteria count, you'd find a whole different picture. He didn't argue with me, he didn't agree with me, but about a year later, he called me and said, yeah, Darrell, you were right. We found all kinds of psychotropic bacteria in the glycol, but no coliforms. This particular slide here shows the same thing for sweet water. Again, sweet water and glycol are used for coolants to cool our product after pasteurization or even during storage. This particular slide shows sweet water, and as you can see, a lot of sweet water samples had counts 60,000 or greater. It can be a tremendous source of contamination. So one might ask, how can this glycol and sweet water get into our product? I showed the difference between a standard play count and a psychotropic bacteria count. As you can see, the psychotropic bacteria count is many, many times higher than the standard play count. The reason for that is the psychotropic bacteria count, we're incubating our plates at refrigeration temperatures, whereas our standard play counts, they're at least at room temperature, even higher. This is a picture showing a high temperature short time. This particular gentleman is looking at the cooling section plates. And what happens when we have cracks and pinholes in the cooling section plates of a high temperature short time, we can have contamination from the glycol and sweet water. This is a very common situation. I've probably been in 100 dairy plants during my lifetime. At least 25 of them had issues with this particular type of contamination. Okay, to control this potential for contamination, we should have pressure controls when we have them when possible. It is, I think, a regulation that you have to have a higher milk pressure than you do a glycol or sweet water pressure. However, during product changes or during desludging of the clarifier, those pressures of the milk decrease, but the pressures of the glycol and sweet water remain the same. Therefore, if cracks and pinholes are in the plates, you will have contamination. One way of monitoring this is effective line sampling, and I will be talking more about that. But the other thing is we're always looking for gram-negative bacteria. If we take a line sample right at the high temperature short time, and we find gram-negative bacteria, we know we have an issue with our high temperature short time, and we need to take action, either replacing the plates or at least identifying those that are defective. A little bit about traditional laboratory methods: the standard plate count, coliform counts, lab pasteurized counts, preliminary incubation counts, the Mosley keeping quality test, sensory evaluation, and line sampling. Of all these traditional methods, only line sampling can be used to identify sources of contamination after the pasteurizer. Recommended test procedures: one is a stress test. This is where we take a sample, for example, right after the high temperature short time. We select for gram-negative to grow, and if there are gram-negative bacteria there, they will grow, and we can find them, we can identify them, and we can take action to correct the contamination problem. Packaging analysis: we talked about putting the sterile milk in the blow molded plastic containers. Very important that we make sure that our compressed air is not contaminating blow molded containers. Determining bacterial types: as I pointed out, bacterial types can be a real asset in helping to troubleshoot problems. If we have gram-negative bacteria, we know we have post-pasteurization contamination. Raw milk screening is effective, but these are not necessarily environmental problems. These are sanitation problems. And then we should be testing our air, the glycol, sweet water, and water for mostly gram-negative bacteria. Gram-negative bacteria love this environment. A little bit about how we can do process sequence analysis. I think on this chart, the two biggest important places to sample is off the high temperature short time and to evaluate our cartons. However, product storage tanks can also be a source of contamination. As you know, the storage tanks are double-walled stainless steel vessels. It's possible that the inner wall can create a crack where you get milk solids and other material between the walls of the tank. When the tank is empty, the crack recedes and you can't really find the crack. When the tank is full, the crack opens up, and what we used to call the dairy industry applesauce is squeezed from the interior of the storage tanks into our product, creating contamination. Okay, to do proper line sampling, we have to have a large sample. Keep in mind that contamination rates as low as 1 bacteria per container can result in defective product. We have to collect the sample aseptically. What do we mean by aseptic? Aseptic means we're doing everything possible to reduce the potential of contaminating our sample with the sampling process. For example, our product is pre-sterilized. It has a sanitary design. It has aseptic sampling collection procedures, and we can be quite assured that when we take a sample, we're sampling the product and not the sampler. The sample incubation requires time, temperature, and oxygen, and we should be looking for whether we have gram-negative or gram-positive bacteria. This shows the effect of oxygen on the generation time of a particular common bacteria for spoilage. It's Pseudomonas. Pseudomonas with a high oxygen level, incubation temperature of 9 degrees centigrade, will have a generation time of 5.4 hours. That will spoil milk in a couple of days. On the other hand, if we have an oxygen level of 3 parts per million and a temperature of 3 degrees centigrade, the generation time is 31 hours, which this particular milk product would last for a long, long time. Appropriate test methods. Again, we talked about the need for oxygen. This particular study was done by the University of Minnesota, where they inoculated milk at 1 bacteria per 15 milliliters of milk. They stored them in bags and syringes. And as you can see, the oxygen permeable bags were the only incubation system that allowed the gram-negative bacteria to grow. And again, what we're looking for is gram-negative bacteria as indicator organisms. In other words, if we find these gram-negative bacteria, we know there's a source of contamination there. And it could be a pathogen, we just don't know. But at any rate, if we find gram-negative bacteria, we should take action to identify what the issue is and correct it. Again, some misunderstanding about line sampling. You have to have a large sample. The contamination rate is very low. The growth rate of the contaminant is important in determining the quality of our product. We have to look at the psychotropic nature of the bacteria. Again, if it comes from glycol, sweet water, water, and any of these cold environments, we're going to have premature spoilage. Shelf life test for line sampling. Again, we have to collect the aseptic sample, place the incubator sample in a sterile container with oxygen permeability, and incubate it for up to 7 days or 10 to 9 days or even more. This shows an aseptic sampling system. This particular sampler is pre-sterilized, has a sanitary design, and it's going into a collection bag that's 2 liters in volume. It'll give us very accurate line analysis. The QMI advantage for doing the stress test: 1 bacteria per container can be identified. We can identify gram-negative bacteria, and we had rapid test results, 2 or 3 days. Again, what we're looking for is gram-negative bacteria. The test results are either we find gram-negative bacteria or we don't. And if we do find them, we need to take action. It's kind of a summary of what I just presented. If we're looking for post-pasteurization contamination, there usually are gram-negative bacteria. If stress test positive, They test positive on our moles at keeping quality tests, and their coliforms can test positive. In line sampling, we find gram-negative bacteria. Heat-resistant psychotrophs, again, these are the bacteria that we find on raw milk handling equipment. They usually are there in biofilms. They're usually sloughed off. They're usually spore-forming type bacteria. However, they test negative on the stress test. They test negative on our moles of keeping quality test. They test negative for coliforms. Line sampling, we find gram-positive rods. Again, these bacteria grow slower than gram-positive bacteria, but they can result in spoilage like at 20 days plus. A little summary: continuous monitoring is necessary for effective quality control program. If we don't have reliable data, we have misdirected quality control efforts. We have wasted laboratory time. We have regulatory noncompliance and frustrated personnel. Our line analysis system fits well with the HACCP system. We can use it to monitor critical control points, and we can document the control of those control points. The principle of quality control, that quality has to be built into the product. It cannot be achieved by finished product inspection alone. That's where line analysis and continuous line analysis are totally necessary for an effective quality control program. Summary: the dairy industry must be a very clean industry. We have a media that grows bacteria very well, perfect pH, perfect nutrients. Everything's there for very rapid bacterial growth. And many sources and mechanisms of bacterial contamination. Again, without good sanitation, without good sanitary design, we will have contamination, but even with good sanitary design and good cleaning and sanitizing procedures, we still can have microbial contamination, primarily due to environmental contaminants, either within the process or from the environment, like floor drains and etc. Psychotropic contamination normally is very low, and our tests must be designed to determine these very, very low levels of psychotropic contamination. Psychotropic contamination determines the shelf life of milk. It's the growth rate of the contaminant that has the most effect. Once again, continuous monitoring is necessary for a successful quality control program. Again, I want to thank you for your time. Anybody has any questions or concerns, please feel free to contact me if you want further information by either email or by telephone call. And again, I want to thank the 3A organization for giving me this opportunity.